Hello friends. In today's video I'm going to be continuing the latest video, so I'm going to put a link to that in the description below. You don't have to have seen it, but I am going to refer back to some of the activities I did in that as I'm developing the ideas here. I'm also going to put a link to this worksheet that I'm using down in the description below, so you can check that out. And here we're going to be talking about types of mechanical energy. The first video was about work and power, and I demonstrated a few ways of doing work and how to calculate work. And so we're going to start building off of that. But the first thing that I did was I showed some clips, some video clips of me smashing chalk. And one way of thinking about energy is it's the ability to do something like smash chalk, right? And so there were three ways that I smashed chalk. One was by lifting a book. So I lifted the book, and then that gave the book the ability to smash chalk. So lifting a book. 2, pushing a cart. And then 3, stretching a slingshot. Okay, and so what was it in each of those cases that gave the object, whatever it was, the ability to smash chalk? So the book had the ability to smash chalk because of its height. So it had energy because of its height. That was it. I pushed the cart, and so I gave the cart motion. It had the ability to smash the chalk because of its motion. And the slingshot, that had the ability to smash chalk because it was stretched. So due to a stretch. So let's take them one at a time. When I lifted the book, I gave to the book what's called gravitational potential energy. And I've seen different ways of abbreviating this, like GPE or just G, but there's also, it's a common accepted convention to use U sub G. U is actually connected to voltage. Voltage is actually electrical potential energy per unit charge. So it's related to potential energy, and the V turned into a U. And so some textbooks will use U as potential energy. So U is potential energy, and it has the G on it to indicate that it's gravitational potential energy. We're going to have other kinds of potential energy. So UG stands for gravitational potential energy. And it says what objects are in the system, how much energy is there if 2 kilogram books is lifted to a height of 1 meter. Okay, so this is important. In order for there to be potential energy because of height, that means the Earth has to be involved. Okay, and so our system, when we're talking about gravitational potential energy, our system is the book and Earth. Those are the two things involved. Okay, now I did work on the book, right? I lifted the book. Now here, like an imaginary situation, like someone's lifting the book. Someone lifts the book 1.5 meters, and the book itself is 2 kilograms. So how much work is done on the book? How much energy is given to the book? Well, the work is F delta X cosine theta. In this case, the force that I'm exerting in lifting the book and the displacement are both in the same direction. Okay, and so cosine of theta is 1, because theta is 0, right? Force and displacement are both up. The angle between those is 0. So we just do the force times the displacement. So what's the force? Well, I'm counteracting the force of gravity. So it's 2 times 10. I like to use 10, round up from 9.8. And then the displacement is 1.5. Now this is equal to how much potential energy it has. The work that I'm doing, I'm adding that into the system. And so that's what I'm giving to the system. So this turns out to be what, 30 joules. So what is gravitational potential energy, and how do you calculate it? So potential energy is energy in a system due to height. That's the key thing. The way that we calculate it, UG, is, well, we just did an example of it. Here what we were doing is we were calculating the work that was done, but it was the work that was done to give that amount of potential energy. And so the way that we find potential energy is just mgh. Okay, so it's m times g times h, where g is 9.8, which we like to round to 10. M is the mass, and h is the height. The units are also in joules, just like work. So joules are our standard units for work and for energy. All the types of energy that we're talking about have joules for their units. Also, I should mention, this is mechanical energy. There are other kinds of energy, like there could be electromagnetic energy. I mentioned voltage, what that is. There's also chemical energy, right? Like when you put gas in a car, the energy that's in the gasoline, it has to do with the chemical bonds. There's chemical energy there. These kinds of energy that we're talking about here are mechanical energy. Okay, so now on to the next one. It says the cart could smash chalk because it was moving. This is called kinetic energy. The way I abbreviate kinetic energy is with a capital K. Okay, and so what is kinetic energy? How do you calculate it? What are the units? Okay, so kinetic energy is energy due to motion. Right? That's why the cart was able to smash the chalk. That's why it had energy. It was because it was moving. The way that we calculate kinetic energy is 1/2 mv squared. And the units are joules. Okay, and slingshot. It says the slingshot could smash chalk because it was stretched. This is called elastic potential energy. And this is a little bit confusing. U is not in potential energy, right, as far as the letters go, the way that you spell it. And the S, think of this as the energy something has because it's stretching. Okay, so U, capital U sub S, that's elastic potential energy, or the potential energy that something has because it is stretched. With springs, it could also be compressed. Okay, and so elastic potential energy is energy due to stretch or compression in the case of a spring or something like that. Energy due to stretch or compression. Okay, the way that we calculate this, US, this really actually depends on the kind of spring, the kind of elastic device that you're using, but there's a standard kind of spring that we call a Hookean spring. You don't need to know this, and the way to calculate the potential energy of a spring of that kind is 1/2 kx squared. Okay, now what do these mean? Okay, K is what we call the spring constant. And the spring constant has units of newtons per meter. Okay, and X is the amount of stretch in the spring. So it's so the length that we're dealing with, it's measured in meters, of course. And the units, the overall units for elastic potential energy are joules. Okay, so 3 types of energy, 3 equations that you need to know. All of them are measured in joules. So here's some kind of practice problems. Imagine there's a pile driver, 500 kilograms, and it's lifted to a height of 30 meters. Okay, so always good to draw a picture of some kind, right? So there's some thing lifting up this huge 500 kilogram pile driver that's 30 meters high. And so the way we calculate gravitational potential energy, that's what we call plug and chug, mgh. So this is 500. This has kilograms on it, so we know that's the mass, times 10 times 30. So this is going to be 1,5. I think that's right, 150,000 joules of gravitational potential energy. 7, what is the kinetic energy of a 300 kilogram car moving at a velocity of 10 meters per second. All right, well, kinetic energy, K, is 1/2 mv squared. So this is 1/2 times 300 kilograms times 10 squared. So 1/2 of 300 is 150. We add 2 zeros to that. So 15,000 joules of kinetic energy. Right, just practicing using the equation, putting the numbers in. Okay, and then 8. What is the elastic potential energy in a spring where the constant is 400 newtons per meter that has been stretched to 10 centimeters? And I already converted this to meters for you. You're welcome. And so the elastic potential energy, US, is 1/2 kx squared. This is 1/2 times 400 times 0.1 squared. So half of 400 is 200. Move this a place twice. So this is going to be 2 joules. One thing that's interesting to notice is that for the elastic potential energy, the mass of the object doesn't matter because it's the amount of energy that's stored in the spring. And then whatever the mass is, if the spring is released, whatever the case might be, that elastic energy will turn into some other, like kinetic energy. And then the amount of kinetic energy or the amount of gravitational potential energy, if it's shot up, that will depend on the mass. But the amount of elastic potential energy just has to do with the nature of the spring and how much it's stretched or compressed. So those are the only two things that are in that elastic potential energy equation. So if the height of a box is doubled, how much does the gravitational potential energy change? Well, UG is mgh. If you double the height, right, then the gravitational potential energy will also be doubled. This is a direct relationship between UG and h. So you can imagine if you double this, if this becomes 2h, then UG is also going to be doubled. So for example, UG2, the second one, is m times g times 2h. If we kind of simplify this, clean it up, mgh. Well, mgh, this is the original UG, so it's twice the original gravitational potential energy. Okay, so 10. So if the speed of a car is doubled, how much does the kinetic energy change? Okay, now this one's a little different. K is 1/2 mv squared. This is the original. Now K2 is 1/2 m. We're doubling the velocity, so 2v squared. Simplify this, and we get 1/2 m 4v squared. Okay, I'm going to bring that 4 all the way out front. So 4 1/2 mv squared. And this is the original kinetic energy. So it's 4 times as much. So I end up with 4 times the original kinetic energy. And if I try the same thing with a spring, so US is 1/2 kx squared. So this time the spring is stretched double, right? So if I double the spring stretch, does that double or quadruple the amount of energy there? And so US is, so that's the original, x squared. So US2 is 1/2 k 2x squared. Okay, so this is 1/2 k 4x squared. Bring the 4 all the way out front. I get 1/2 kx squared. And this is my original US formula. So this is 4 times U, the original elastic potential energy. So by doubling the stretch, I quadruple the elastic potential energy. Okay, and so there you have it. An introduction to the different types of mechanical energy, gravitational potential energy, elastic potential energy, and kinetic energy, how to calculate them, how to manipulate them, and the next lesson is going to be about conservation of energy. How do all these types of energy affect each other and turn into each other? given a particular system where there are particular processes that are happening. So don't forget to like and subscribe. Thanks for watching.